right. So today we're going to look into something that honestly sounds a little intimidating at first.
Yeah.
This whole intersection of category theory, logic, and then formal linguistics.
Right.
But, our listeners are curious about this kind of stuff.
Yeah.
And they want to understand it, but without feeling like they need to go back to school and get a PhD.
Yeah. No, that's a good point.
So our kind of mission today is to translate all that academic jargon into something that actually makes sense to, a normal human brain.
Yeah. Well, I think that's a great mission. And I think it's important, too, because all of these fields are actually a lot more relevant to our daily lives than a lot of people realize.
Exactly. And we're going to kind of see how these ideas that might seem super abstract, at first glance, actually kind of underpin how we think and how computers work and even how we use language.
Absolutely.
Let's get started with this thing called intuitionistic logic.
Okay.
Which seems to be kind of at the root of a lot of this stuff.
Right.
I've seen it in your sources on type theory and categorical logic. But honestly, it sounds kind of intimidating.
The name might sound a little intimidating, like it's right out of a philosophy textbook.
Right.
But it's actually a very straightforward idea.
Okay.
Imagine like you're trying to prove something's true. But you can't just say, well, it's either true or false, so it must be true.
Right.
Instead, you have to actually show how it's true, step by step.
Oh, okay.
Like building a Lego model.
Oh, I like that.
Yeah.
So it's less about making a declaration and more about showing your work.
Exactly.
Like instead of just saying, this cake is delicious, you have to show me the recipe and the process of how you baked it.
That's a great analogy.
Okay.
Yeah. Intuitionistic logic is all about construction and demonstration. It's a different way of thinking about proofs and truth.
Okay.
And that has huge implications for fields like mathematics and computer science.
Okay. I'm starting to see how this show me, don't tell me logic could be useful. But then our sources bring up categories, which they describe as collections of objects and arrows.
Yeah.
And honestly, I'm having trouble picturing how that connects to anything real.
Yeah, so think about categories as a way of organizing information.
Okay.
The objects can be anything. Numbers, words, even people. And the arrows represent relationships between them.
Okay.
So it's like a map.
Okay.
But instead of showing physical locations, it shows connections between concepts.
Oh, so like on social media, people are the objects and the arrows are things like friends or followers.
Exactly.
That's how the platform recommends new connections, by following the arrows.
Exactly. Categories help us see patterns and connections that we might otherwise miss. And they're not just limited to social media either. They pop up in math, computer science, linguistics, even physics.
So categories are like this secret organizational principle that's working behind the scenes in all these different fields.
Yeah.
That's pretty cool.
It is cool.
But then things get even more interesting with this thing called sheaves.
Okay.
Our sources describe them as a way to glue local information together to get this global picture.
Right.
And honestly, it kind of sounds like science fiction to me.
Well, it's actually a very intuitive concept.
Okay.
Think about a jigsaw puzzle.
Okay.
Each piece contains some local information, but it's only when you put them all together that you see the whole picture.
Right.
Sheaves are like a mathematical tool for doing that.
Okay.
Taking lots of small pieces of information and assembling them into something bigger.
Ah, okay. So it's like building a mosaic.
Yes.
Each tile is a piece of local information.
Yes.
And the sheaf is the process of putting them all together
to
create the overall design.
Precisely.
Oh, yeah.
And when you combine sheaves with intuitionistic logic, you get this really powerful framework for modeling complex systems.
Okay.
In fact, this is how we can go from understanding single words to the meaning of an entire paragraph.
That's amazing.
It's like a computer program figuring out what your email is really about.
So we're going from the logic of proofs to understanding how language works.
Yeah.
All thanks to these seemingly abstract mathematical tools.
Exactly.
But our sources don't stop there.
No.
They also bring up linear logic.
Okay.
Describing it as a refinement of intuitionistic logic, where we pay attention to resources.
Yes.
Honestly, that sounds a little cryptic to me.
Okay, think about it this way. In linear logic, you can't just use something over and over again without consequence. Like if you're baking a cake, you can't use the same egg twice.
Oh, I had a baking disaster once where I totally forgot an ingredient, and the cake was a total flop. It's like my brain was working with linear logic.
Right.
But I wasn't paying attention to the resources.
Exactly. Linear logic captures this idea of resource consumption.
Okay.
It helps us model systems where things are finite and actions have consequences.
So it's like in a video game where you have limited ammo and health points.
Yes.
Every action you take depletes your resources.
Right.
And you have to be strategic about how you use them.
That's a great analogy.
Okay.
And it turns out this kind of logic is incredibly useful in computer science, where resources like memory and processing power are always limited. It even helps us understand how meaning is constructed in language.
Okay.
Where each word we add to a sentence changes the overall meaning.
Right.
It's all about understanding the process and the consequences of each step.
Okay. My brain is definitely starting to feel the burn here.
Yeah.
But in a good way.
Yeah.
We've gone from the foundations of logic to baking cakes.
Right.
To video games, all in the span of a few minutes.
That's right.
But we're not done yet.
No.
There's another fascinating concept I want to introduce you to called coherent spaces.
Okay.
Imagine a graph where the important information isn't the individual points, but the groups of points that are all connected to each other.
All right.
So instead of just looking at individual people, we're looking at the cliques they form.
Exactly.
Like at a party, it's more interesting to see who's hanging out with whom than to just see a list of names.
Exactly. And the amazing thing is that these coherent spaces, when combined with linear logic, can actually represent logical proofs.
Wow.
And even aspects of language, meaning...
That's mind-blowing.
Yeah, it's like finding this hidden mathematical structure.
Wow.
Underlying how we think and communicate.
We've gone from abstract logic to social dynamics to language and proofs.
That's right.
It feels like we're uncovering this secret code that unlocks a whole new level of understanding.
Yeah.
And we've only just begun to scratch the surface.
Right. That's right. There's so much more to explore in this fascinating world.
Wow.
Where logic, categories, and language intersect.
Well, my brain needs a little recharge before we jump back in.
Okay.
Let's take a break, and we'll be right back to dive even deeper into these mind-bending concepts.
Sounds like a plan. I'm ready for more.
Me too. Okay, so we're back. And before the break, we were talking about these coherent spaces, which are kind of like these social network diagrams where you're really focused on the groups, not the individuals.
Yeah.
And what really blew my mind was hearing that those groups can actually represent things like logical proofs.
It's pretty amazing. And that connection between these abstract mathematical structures and the logic of human thought leads us to something even more intriguing.
Okay.
One of your sources suggests that category theory can actually model the structure and meaning of natural language.
Hold on, really. Language is messy.
Yeah.
I mean, people lie.
Epic. They're sarcastic. They use emojis.
Yeah.
How can categories handle all of that?
It might seem counterintuitive, but think about it this way.
Okay.
Language at its core is about combining elements, words, phrases, sentences, according to rules, to convey meaning.
Right.
And that's what category theory is all about, understanding how things combine and how meaning is constructed through composition.
So you're saying that category theory can be like a blueprint for understanding how language works.
Exactly.
Kind of like how a musical score shows how different notes and instruments combine to create a symphony.
That's a great analogy.
Okay.
Just as a musical score dictates how different musical elements come together to create a harmonious whole, category theory can help us understand how linguistic elements combine to create meaningful sentences and even entire discourses.
Okay, that makes sense.
Yeah.
But what does this categorical approach to language actually tell us?
Like, what are some of the practical insights we can gain from it?
Well, for one thing, it can help us understand how sentences are built.
Okay.
Not just in terms of grammar, but also in terms of their underlying logical structure.
Oh, okay.
It's like seeing the hidden scaffolding beneath the surface of a beautiful building.
So we're not just talking about subject, verb, object, but about like the deeper connections between ideas within a sentence.
Yeah.
Like how a well-written sentence builds momentum and leads the reader toward a conclusion.
Exactly. And this goes beyond individual sentences.
Okay.
category theory can also shed light on how meaning is composed across entire discourses, like paragraphs or even whole texts.
Okay.
It's like zooming out and seeing the big picture of how ideas flow and connect within a larger context.
So it's kind of like mapping out the architecture of a story.
Yeah.
Seeing how each sentence and paragraph contributes to the overall narrative.
Precisely. And it gets even more interesting.
Okay. When we start thinking about how this framework can be applied to different languages.
Are we talking about a universal grammar here? Like the idea that all languages share some fundamental structure?
Yeah.
I remember reading about that.
Yeah, it's not necessarily about finding a single universal grammar, but rather about identifying shared underlying structures and patterns of meaning construction across different languages.
Right.
It's like finding a common language for understanding language itself.
So it's less about finding a literal one-size-fits-all grammar and more about understanding the fundamental building blocks of meaning that all languages share.
Exactly. And this opens up a whole new world of possibilities for things like machine translation and cross-cultural communication.
Right.
If we can understand the deeper structure of meaning, we can build better bridges between languages and cultures.
That's incredible.
Yeah. It seems like we've gone from abstract logic to social dynamics to the very essence of human communication.
That's right.
It's like these tools are giving us a whole new way to see the world.
It's a powerful reminder that even the most abstract ideas can have very real and practical applications.
Yeah.
And it speaks to the incredible interconnectedness of knowledge.
Right.
How seemingly disparate fields like math, logic, and linguistics can all contribute to a deeper understanding of who we are and how we communicate.
My brain is buzzing with all these new insights.
Yeah.
We've covered a lot of ground today.
We have.
From the foundations of logic to the structure of human language.
Right.
I think it's time to take a deep breath.
Okay.
And let all this amazing information sink in.
I agree. We've only just begun to explore the vast landscape of ideas that connect these fascinating fields.
Well, I'm ready to keep exploring.
Me too.
We'll be right back to wrap up this deep dive and see where these ideas might lead us in the future. Okay, so welcome back to our deep dive into this world where like category theory and logic and linguistics all kind of come together.
Right.
We've been on quite a journey.
Yeah, it has been quite a journey.
From like baking cakes to the structure of language, it feels like we've uncovered this whole new way of seeing the world.
I think so. And, you know, I'm really impressed with how you've grasped these concepts. It's really,
Thank you.
It's a testament to the fact that even the most abstract ideas can become accessible if we find the right way to connect them to our everyday experiences.
I couldn't have done it without you, honestly.
Oh, well, thank you.
But my brain is still kind of buzzing with all this. Yeah. If category theory can apply to language and physics and computer science, like what other unexpected areas might it illuminate? What other mysteries are out there waiting to be unlocked with these tools?
I think that's what's so exciting about these fields is that their applications are vast and largely unexplored. You know what really fascinates me is this idea of uncovering hidden structures and connections.
Right.
The more we look, the more we find that all these seemingly separate fields are actually interwoven in these really profound ways.
It's like we've been given this new lens to see the world through.
Yeah.
And suddenly all these patterns and connections are popping out that we never noticed before.
Right.
Makes you wonder if there are other codes out there waiting to be cracked.
I think so. And I think that category theory and logic and formal methods can play a key role in that.
Yeah.
They provide this framework for thinking about complexity, for finding patterns in chaos, and for bridging the gap between these different domains of knowledge.
So what's the one key takeaway
that
you hope our listeners will walk away with today? What's the one thing you really want them to remember about all of this?
I think the most important thing is that even the most complex and abstract topics can be accessible if you approach them in the right way.
Right.
It's all about finding the right analogies, the right examples, the right stories to bridge the gap between the technical and the human.
Absolutely.
Yeah.
We don't have to be robots to understand these ideas.
Oh, we don't.
It's all about embracing curiosity, asking questions, and finding those aha moments that make learning truly rewarding.
Absolutely. And who knows?
Yeah.
Maybe some of our listeners will be inspired to make their own contributions to these fields.
Right.
to uncover even more surprising connections and to push the boundaries of human understanding.
That's the amazing thing about knowledge. Yeah. It's this never-ending journey of discovery.
Yeah.
And I am so glad you joined us for this leg of the adventure.
Me too.
Keep those brains buzzing, folks. And until next time, happy exploring.